What's going on, guys? My name is Hussein. I wanted to do a quick video to discuss this topic, which is very interesting to me. And I think anyone who works with databases should really understand the underlying data structure of how databases store stuff, because it will really become really handy when you scale. It will really become handy when you design your backend application, how your queries actually access the path of your path, and then you're pulling the data, how the planner actually makes decision, and all of this really comes down to indexes. And in this video, I want to discuss how specifically just Postgres and how MySQL, specifically NoDB as a database engine in MySQL, stores their indexes. Before we jump into that, we need to understand the basic architecture of tables. So if I create a beautiful table on my database, what does that mean? Right? A table has, well, it has columns, and each column will have a specific data type, which is integer, string, and number, dates, right? JSON, I heard, is a good data type these days, and you guys convinced me that's actually a good idea to store JSON as data. So yeah, a table will have multiple columns, and each column will have a specific size, and that decide the row size, and that row size will become either dynamic or static based on how you defined it, right? Varchar versus just normal text, and so on. And that the table is huge data structure. It's big, and it's usually stored in disk, and unless you can put it in memory, which is awesome for fast access queries, but usually it's in disk because it's a blob, huge of just blob, right? So now it comes to indexes. Index, and I made a video about index. Check out this video right here to learn more about them. But an index is basically another data structure different than the table that tells us where exactly the rows I'm searching for are, right? And then the easiest way I understand the indexes is like, you know, these alphabetical dividers, binder dividers, where it says A, B, C, D, E, E until Z, right? And then you're searching for a specific, like, I don't know, company or phone number, right? So if you're searching for a company, Zebra, I don't know, those companies. So you will jump to the Z divider and then start searching for that. So you have a smaller subset. So what the index does in this case is actually stores a pointer to the first row in where the Z's starts, essentially. So that's essentially how the index is always like a pointer. So the row, the table, the big stuff, and there's another data structure that you can have a quick access index, and it points to the row. Not every database does that, though. How about we start with Postgres? Every index you create in Postgres does exactly that. So if you create an index on column A, it's gonna create that data structure for you, the beautiful data structure, and each leaf, each entry will be pointing directly to the table, directly to a unique identifier in the table. That's not the primary key necessarily. That's just a row that is most of the time it's invisible. In Postgres, I think it's called the tuple ID. So that's the data structure. So if you create an index, it points to the row. You might say, Hussein, what's the problem with that? No, really, no problem, but just pay attention to that. If I create another index, Postgres, what does Postgres do? It also still points to the table directly. You see a pattern here, right? The more indexes you create, all of these are actually pointing to the table, which is pretty neat. So, and then that makes sense, right? If I'm searching something in this index, I find it, I jump to the table, I pull. If I need to jump to the table, that's what's called index only scan versus an index scan, right? And if I only need to jump to the table, I know where to find my data. So indexes in Postgres all point to the table directly. MySQL, and specifically AnoDB in MySQL, because MySQL has other database engines that you can swizzle and can change, which is something I love in MySQL and MariaDB. Something you don't see in other databases. We can swizzle the database engine of a table to be something completely different. MyASM is a different database engine that it works exactly almost like Postgres. It points directly to the table. Each index you create, it points to the table. AnoDB, which is the default MySQL engine, doesn't do that. There is always a primary key in the table. And when you create that primary key, or if you don't, AnoDB or MySQL creates one for you. And then that primary key index points to the table, right? But any secondary index you create or any other index you create does not point to the table directly. It points to the primary key value, which corresponds to the table. Multiple hops. There's a careful design choice for both. And let's explore both of them. So we know Postgres, every index points to the table directly. MySQL, every index points to the primary key, and the primary key is the only index that points to the table. So now if I did an update in both databases and I updated a row, right? Or deleted a row. In Postgres, if I deleted a row, right, and that row doesn't exist anymore, I have to tell index number 1, index number 2, index number 3, index number 4, index number 6, that row doesn't exist, because guess what? All of them actually are aware of this table. So they're dependencies. So Postgres, when you update this, it actually goes and update all indexes. That doesn't mean it's slow or bad. It's just that's what it does, right? And MySQL, when you update a row or delete a row, it just updates the primary key, right? Because that's the only thing we need to do. Because these guys will still point to the primary key index, and that's it. They are not aware that a row has been deleted, right? So that's as long as you don't touch a specific value. Like for example, if you updated another column in a row, that the index on which this is created need to be aware, right? And that is, in that case, you will need to update that index anyway, but only the index that you actually touched for the columns you touched, right? So that's how things work in general. So, hey guys, Hussein from editing, and I forgot to mention one thing. In MySQL, remember, every index points to the primary key, and primary key points to the table. So if you did a lot of updates on the primary key, guess what will happen? Every single index will need to be updated. So really careful while updating primary keys in MySQL. So that's another kind of something to be aware of. I'm not gonna say limitation, but just something to be aware of. Back to the video. In updates in MySQL versus Postgres, you can see that it's a little bit less scattered. Reads, however, if I read in Postgres using an index, I'm gonna find the value I want. And if I ask for a row that doesn't exist in an index, it's not included in the index, I have to jump to the table, and I can jump very quickly because I immediately look at the table. I have the row that points to the table directly, and I read it. So reads in Postgres are extremely fast. Does not mean that reads on MySQL are slow. It's just understand how things work, right? So now if I'm reading a particular table in MySQL and I'm using a specific index and I found what I'm looking for, I cannot jump and I need another value to select from the table. I cannot jump to the table directly. I have to jump to the primary key index, and then from the primary key index, I get the row, and then I jump to that. There is an extra hop. So reads are a little bit, tiny bit slower. Sometimes it's unnoticeable, but just understand, if you're doing this a lot, understand what's going on. So if you're, but the beauty of this, if you're selecting the primary key a lot in MySQL, that's really beneficial, because the primary key is almost always included with every index. So the choice of what becomes the primary key in AnnoDB becomes really critical, and it can boost your performance in an amazing manner. While in Postgres, reads are fast, right? Because any heap value pulls, like pulling from the heap or pulling from the table, are also pretty extremely good, because you're pulling to the table directly, right? Obviously, doing it overdoing everything is just basically slower, but that's just something that's very interesting to understand when you deal with these things, right? So Postgres, updating a lot of rows or deleting a lot of rows might trigger a lot of update to a lot of indexes. So just pay attention to that when you do that. And that's it. That's what I wanted to talk about. Obviously, I want to make this video short. What do you guys think? There is always a choice between Postgres and MySQL on any other database. Doesn't mean Postgres is bad. Doesn't mean MySQL is good. Doesn't mean anything. It really depends on what you're trying to do. Uber, I believe, one of their main concerns of moving from Postgres to MySQL is exactly that. They had tons of indexes. I was surprised, like, why do you have this much indexes? Like, too much indexes, too many indexes. And as a result, touching rows, if they touch a lot of rows, update a lot of rows, it just thrashed all the indexes, because it needs to update all the indexes. You need to let everybody that points to the table know that something has changed, right? Especially if you update, if you insert, if you update, these things are all scattering everywhere. And Postgres is like, it's a little bit different when it comes to updating versus deleting. They keep the rows alive for MVCC reasons. All right, guys, gonna keep the video short. I'm gonna see you in the next one. What do you think about these two beautiful databases? What do you prefer? Let me know in the comment section below. I'm gonna see you in the next one. You guys stay awesome. Goodbye.